Hello, hello, hello. We are back, Theo.
Hello, hi Luca, and we are back. Wow,
Yeah,
another week at the Banter. How are we doing?
after a week that we were a little bit busy, finally we are back. Great to be on the ground, even if I don't think I'm gonna last long on the ground. But I was excited about the chat that we are gonna have today. It's
Yeah,
a dear topic.
absolutely. Distributed systems. We started more or less this podcast with distributed systems in mind, and
Yeah,
we keep coming back to distributed systems. So
well,
it's our
everything is a
bread and
distributed
butter.
system.
Yes, it's our
Uh,
bread and butter. So
yeah, and well, where to start? Let's start from where? I think our chat should start from Once Upon a Time. That
yes,
is the old time ago when I think we are going back probably 20 years when we were in the world of the ESBs, right? Enterprise Service
wow.
Bus, the world of SOAP, when system needed to communicate with each other, and we started to kind of like put a broker in between, the so-called Enterprise Service Bus. And clearly we remember the famous Oracle one and the Microsoft version, so Bitstock. And the goal of these systems was to basically handle coordination between integration systems and system of records within the organization,
Yes.
but also to create like a common layer of communication between them. And the main topic was that a task might take an indeterminate amount of time to be executed because we don't know exactly the length of the state change, but that we make stateless system and we try desperately to do it, every system goes back to a state. If you think, for example, that when you go and buy some groceries in a supermarket and you collect the points, right? This is like a state
Ah,
mutation on your
yes.
wallet, right?
Yes. Yes, it
Uh,
is. Yes, it is.
Even the banks, right? When you add money is a state mutation on your balance. So there's always this thing of state mutation over time, and the fact that the transaction then is a very long-lasting transaction, right? Is
Yep.
incrementing, is mutating a long time. So yeah, and we came to 2025, the moment when we saw many systems kind of like, um, joining the open source ecosystem, joining the front end ecosystem. But I think before we delve into that, I think it's interesting to bring to surface that there was a company that back in 2016 kind of like figured this thing out a little bit ahead of many others. Was Uber, when they basically said when you order a cab, ordering this cab is a state mutation, and all the status of these cabs to be available or not, these drivers, is also based on state mutation. So they were the first one to kind of like approach this problem at distribution. But let's jump into the world of Node. By the way, Uber was Node at the time. Now clearly Go. But yeah, and the magic world of workflow engine, because that's been become from N8N to Node-RED to many other. They kind of like took. They became popular, and now especially with AI and agents, they became even more popular. But yeah, let's go there, and probably Kafka is
And
going to
then,
be still there.
yes, we have Kafka. Okay, of course, in between, which is probably the most modern thing for doing those kind of stuff. Then we got Temporal, which very interesting. And finally, the latest addition to the show, the Workflow Dev Kit from Vercel, which wants to be the next JS for backend. So it's we have all of those things, and it's a long journey. Okay,
Yeah,
And first of all, let's talk a little bit what is the key problem that all those tools kind of solves to some extent. Okay, and you I think you touched briefly into that. Okay, which is when you are implementing a digital system, okay, an application, an agent, whatever it is, it doesn't matter, an API, okay, you need to respond quickly, generically, which quickly depends on the system, but typically in the scale of milliseconds, okay, might be in the scale of minutes, but that's slow, okay, definitely not in the scale of hours, okay, because we all know that there are the big scissors of the net that are passing by and cutting connections, and connection can fail at any given time. So having a request that lasts for a long time is really bad for user experience, as well as it has very high likelihood failing. So,
Also has a physical limitation, right? Because then I title couple the number of
yes,
file descriptors with the number of people on the planet.
Absolutely. So we want to be very quickly open and close. So this means that if my processing cannot be done in just a few milliseconds of processing, okay, I need to do it. I need to start some asynchronous computation, and finish that later on. Okay, a lot of this is to some extent it falls in the topics of a lot of this has been explored by domain-driven design, CQRS, command query responsibility segregation, patterns, and so on and so forth. Okay, event sourcing, all of those things. Okay, follows a little bit of that kind of pattern of I have data that I can more or less read very quickly, and then if there is any mutation on the data, it's done over time. Okay, it takes a long time to process that. Okay, so a little bit long time to do the processing. Why? Because I need to very often to do a lot of things after the fact. Okay, so I think there are a few key ways in which this kind of system could be done and implemented. Okay, and they have been done, in a lot of different ways. And a lot of the discriminator here is, the various axes, I think, in which you can evaluate all the techs, all the various technologies are reliability. Okay, you don't want to miss anything. Okay, I would call it observability. You need to know what's happening, and you need to know what happened and when and how and why and all sorts of things. A lot of those systems work in regulated fields, so you need to keep an audit log, essentially, of what things happen or what happened. Okay. Last is essentially developer experience or developer velocity. Okay, how much time it takes for a team to get this shit done, essentially.
Yeah.
Because to be honest, developers are not cheap. Okay, and you need to have experienced engineers to build those kind of systems. So, first queue system that I used to interconnect things was I think ActiveMQ and then RabbitMQ. Okay, I think those were kind of the first, but it was a long time. Apart, there was the ESB, of course, the Oracle ESB. Yes, there was the.
But there is something, right, that probably we forgot to mention. That is the kind of like concept of transactionality, right?
Yes, exactly. Yeah.
So the thing is that the reality is that there are two major problems. The first one is that every single operation in the real world is still transactional. Right.
Yes.
I mean, that we like it or not is a composition of different actions that they result in cause and effects or causality. The other thing that is kind of like pretty interesting to address is that, and you said it, is the reliability, right? So how do I do transaction rehydration in case of failure? How can I make sure that the system doesn't go in a faulty state because I'm trying to reprocess operation, or my state is pending, iteration. So I think what Bitstock at the time kind of like was extremely strong was the concept of transaction iteration. So if I stop an operation, I can restart exactly at the point where it was stopped and continue. And in these kind of like modern systems, especially with agents, this is kind of like extremely common, as you said, because there is the concept of time. Like an operation goes for an undefined amount of time, and I don't know if it will succeed, fail, what's going to happen, right? So I think that's a very important kind of like thing. But yeah, no,
And
please continue. I think it was
idempotency. Idempotency. That's
yeah.
how it's spelled.
So
Idempotency.
the yeah, because clearly we are in a system where concurrency is in place, right? And ergo, we want to actually operate on idempotent operations. But the thing that is interesting is a lot of people, they told me, yeah, it's very simple. I embed everything in a store procedure in a database, and I do a transaction, which kind of like is not false, but it doesn't work in a distributed system, right? So probably it's interesting to deep dive into that.
Maybe not. Just don't.
Yeah, no, but basically what these workflows are doing is kind of like the same, right? So if a step fails, they roll back the state, and they for each step they have a status checkpoint, right?
Yes.
So they implement the concept of transactionality per step. They do commit only at the end of the workflow or when you tell the workflow to commit. But I mean, probably let's go into the connection between Node, the workflows,
I
and these
wanted to
systems.
chat a little bit on using, first of all, using queues of one side, and then using what the name? Using queues, then using Kafka, okay,
As a broker.
as a broker, okay, and then using the complexity in developing those systems, okay, and then using temporal, and then finally using use workflow, and so on. So
So
the first,
temporal, by the way, just open and close bracket is the commercial version of a product that the Uber product that I mentioned is called Cadence. So if anybody, they come from the same source. But if anybody wants to check, Cadence is the system that Uber uses.
so the problem, part of the problem is when building this kind of queue-based systems, okay? So how do they work? You have one process, one pod, one process, one lambda, whatever, that write a message to a queue, okay? That queue, and then you have another process somewhere, another program that pulls the message from those queues, okay, and do some processing, okay, on those things. If things fail, they go back into the queue to be reprocessed again in the future very often. After a little bit of time, they go in what is called a dead letter queue, which is another queue at the bottom, right? Which keeps accumulating things, okay? We get the error, okay? If the retry, to avoid infinite retries problems. So that's the queues, okay? However, you typically don't have one queue, okay? Let's say that you have a complex state machine or a complex program that needs to be, that has, I don't know, 4 or 5, 6, 10 steps, okay? That happens with some significant delay of time between each other, okay? So typically it can be, measuring processing on a queue, okay, there is some kind of long time operation that needs to complex operation that needs to happen, then it goes into another queue, okay, because I want to save the intermediate step, okay. The key part here is if I have a long chunk of processing that, I don't know, it's maybe will take 5-10 minutes to do because it's complex, it's a lot of work, okay, might be a lot of work. I am interleaving it inside in steps in between, so that and having those systems communicate with via queues. Okay, so that the intermediate steps are always saved and can be resumed. If one fails, I'm not losing everything, but things can be debugged and restart. I built in incredibly complex system in this way using SQS and using SQS or Rabbit and so on and so forth. You could go as complex as you want, okay, in these systems, okay. They work very well, but they require like you need to manually break the execution down and handle all these individual steps separately, essentially a separate deployment almost. Over there.
Well, plus there's the complexity that you are basically taking a set of operations that they are atomically a transaction, break it down into steps. If a step fails along the way, you need to handle the rollback
manually
or state alerting, and then kind of like dismiss everything, put in the dead letter queue. I mean, I think queues, they are interesting, but they are a little bit kind of like lame, if you may, in building all the thing, because yeah, at the end of the day, it's a queue, but I mean, is there any better system to do that?
Oh, you know there is a better system, right? Kafka,
Well,
Kafka is Kafka a better system?
but Kafka is not enough, right?
Exactly. Okay, Kafka is not enough. Kafka is a phenomenal thing to stream events. Okay, is a phenomenal thing to stream things that happens and replay those things that happened. Okay?
Correct.
Is phenomenal for that. Okay, you can increase massive throughput. Okay, it's a clear way to guarantee that given an incredibly high amount of data in input, all that data gets processed in order, okay, and everything is managed correctly, okay. For that, Kafka is one probably of the best tools on the planet, okay. It's also, given it's a log, essentially, it's you know, you can replay, so you can go back from the beginning of all the messages being sent and replay all of them, okay. It is essentially the ultimate write log type of thing, okay. You could essentially use Kafka as your essentially source of truth and replay it from the beginning. Having said that, this sounds very cool in theory. You are probably not rebuilding your production database from scratch, okay? Replaying all the log, okay? I seldomly, minus very dangerous situations, you're probably not doing that very often, okay?
No.
So there is that, okay? Kafka as a system for sending messages across microservices, across processes. I don't know. It feels the wrong tool for the job, or in other terms, it seems, oh, let's put Kafka everywhere because it's so cool, okay, and be done with it, okay. What do you think?
I think the modern engineer suffers of the cool boy syndrome. It's cool to build system with Kafka, clearly, because it's a cool toy. But like you said, it's just, I think we need to kind of like go back to basics and explain. I don't think many people really understand what Kafka is, to be honest with you. Like, we saw it also with a lot of customers, a lot of people. It's a very complicated system. It understands perfectly the concept of distribution, event consistency. It's perfect to build an event source distributed system. Like, it was designed to do that. But to build a workflow, to build a system that is distributed and stateful and high available and resilient, there are many more tools that we need to use. Like, for example, a lot of people, they might say, but I can set the state in Redis, right? And continuously mutate through event the status, right? But what about concurrency in the distributed system? You don't have a single node. What about if the step that you design as a multiple sub-steps of execution, right? I think if I had to pick a combo, I would probably do Cassandra or similar and Kafka, just because you still need to persist this somewhere, right? You still need to have a place where this state is handled, is persisted, mutated, retrieved. So yeah, it's a cool toy, but not enough. It's like going into a kitchen and try to cook with just a knife, right? It might be enough, but you need something else. Okay, but so we have Kafka that basically becomes a glorified choreographer, right? So it's the so-called choreography pattern. So okay, Kafka is on top, and we know that Kafka there is some sort of like entity. We call it the entity, and like in James Bond, and this entity understands knows how to unpack basically the concept of transaction and uses Kafka to broker it across different workers that are executing the work. Correct? Some sort of like high level.
Yes.
But I mean, we spoke about cadence and temporal. So what's the difference between like cadence, temporal, and
Okay,
just
so
using Kafka?
the major difference, so the major difference with temporal and between temporal and building something on top of Kafka of queues, okay, is essentially it's the level of abstractions, okay, specifically the SDKs, okay. There is a lot more going on in the SDKs, okay, for temporal. Temporal allows you to set it up, okay, in allows you to write more or less ergonomic code, okay. The developer experience is essentially fixed by was essentially fixed by temporal for those kind of use cases, that you can essentially write your workflows more or less in normal code, and temporal will make sure to make everything work correctly. Okay.
Well, because it's a client server kind of like model, right? So the code that you write is the client and temporal is the runtime, right? So you have some
It's slightly
instruction.
different. Okay, so basically, each the code is divided between the workflow definition, and instead of using, I don't know, in the ESB lingo, okay, a very complex workflow definition in XML or with
So a DSL basically.
a DSL, okay, without having the defining the workflow with a DSL, okay, it defines the workflow with the code in code, okay. You can define your workflow just using TypeScript or Python or whatever you want to, okay.
But I could do the same with promises, right? I could do the same in JavaScript chaining promises. That's a workflow, right? When I do a waterfall, it's basically
No,
the
you
same.
can't, because the difference between the SDKs, the SDK, this kind of system as the SDKs is a client server model. And while you write yourself a nice promise and so on, and you do a wait, okay, in reality, what happens is that the client talk to the server and restore the calls to the exact moment. So you can essentially pause a workflow for a long time, okay. While it's being everything is being resolved correctly, okay.
Yeah, because you have all the client, the workflow code
Yes.
that basically gets shot to temporal. Temporal understand the concept of what at the time, at the old good time of Nojitsu, you basically run inside of your probes or your carapaces, and then it basically executes. So he basically goes and pick up a worker that can do it and associate that code, that step with a worker. So he basically does all the coordination and the complexity of handling, the chain of state, the routing, and so on and so forth, right?
Yes. Note that my understanding is that the code runs in your worker. Okay.
Yeah.
You only pass the definition down to the system, to the broker.
Yeah.
Okay.
Yeah.
Which is very cool, to be honest. I find it extremely. I think it's a very novel way, and very. It solves the developer experience kind of approach. Okay.
Yeah.
For this, however, those SDKs are a little bit complex to use. You need to know exactly what's happening. You need to know a lot of temporal things. Okay, to make them work.
So it's very, let me say, it's very vendor locking.
Yes, it's very vendor locking. Yes, it's
the ESB
was super vendor locked.
Super vendor lock. Then you have the queue mechanism that is more kind of like do it yourself. So you can
and that you could use whatever. You can replace whichever queue you wanted, and everything will work correctly.
And then we have Temporal, which is vendor locking.
Yes.
Well, even if it's open source, right? Most of the code is open source.
It's open source. It's open source, but let's see the license. Actually, I have no idea. I have not checked. This is interesting, right? Like live checking on things. Written in Go, not surprisingly. Yeah. And the license is MIT. Okay.
So they're very fair. They're not so vendor locking. I can just like run it myself, probably with a lot of features that are missing and so on. But let's say it's the same model that kind of like we do in a nutshell, right? Yeah. Okay, super cool. And then it's language specific, right? Because every SDK can run multiple runtimes, but every SDK is
its own thing. Yeah.
Yeah.
You need to use the SDK but you have the Go SDK, the Java SDK, the PHP SDK, the Python SDK, the TypeScript SDK, the .NET SDKs, and the Ruby SDKs.
No Zig.
There is no Zig, Luca.
I don't know who
uses it. Like I think I know very few interesting open source projects that use Zig. That are all very cool. But
OCaml? No OCaml support.
No OCaml. Well, see.
No
Elixir neither, Luca.
So that's an interesting question, because I was going to ask you another thing, right? So what do you think they use behind the scene to execute the sandbox, to run the step? Because the step is in a sandbox, right?
No, I think the steps are running down in the process. They're not executed up.
So I have this humongous temporal cluster with probably a primary, secondary model.
They only maintain the state.
So they write it in a database.
Yeah, I think so. Yeah, they are a database. That's my understanding.
Yeah, so true. I was going there. So by analogy, every workflow becomes a database in a nutshell, because they write and read state from a key value.
Yes, right? Yeah.
So my question is, so this one, they're all run inside of this process, like they spawn processes on machines, basically.
Yes.
Okay. Cool. And so they do also the orchestration of all the processes in the distributed system. So they know
exactly. So they assign. Oh, there is this step that is now can be. Let's say there is an await step or a step that finished for whatever reason. Then it can be resumed. Then you can. It restarts the workflow from that specific point, and so on and so forth.
Cool. So can we simplify saying that basically they adopt a model where they put a developer-friendly interface on top of a system that handles kind of like processes in a cluster, basically, like to simplify, right? And then those processes, they do read-write operations. They are basically an input-output function in a nutshell, right?
We are oversimplifying, but yes.
So can I make an oversimplification and analogy that probably will trigger everyone in the universe to kill us? But Lambda then absurdly is a workflow primitive. Could be a workflow primitive.
It's a step. So it's not a workflow. It's a step, I would say.
Sure, it's a step primitive. Sorry, you're right.
Primitive.
It's a step primitive.
Step primitive.
Okay. But then, okay, we are talking about Temporal, that is a system that is massively used in backend system for massive scale. Netflix uses, Uber, our customer Mediaset is huge, right?
It's huge.
And now last week, right? Yeah, last week there was the use workflow. Yes. I know because you guys wanted to send me there.
Yes, I wanted you to go there, but you didn't. But
I didn't.
Was announced at the Next.js conference.
Ship AI conference.
Oh, Ship AI.
Yeah.
Okay.
So now we have use workflow.
Okay.
So Temporal runs all at runtime. There's no compile time, right? It's very dynamic. I can add steps.
It's all right? Yeah.
And how does it work with Vercel? Can you tell us something more?
It's actually very interesting. So, okay, it's very interesting. Okay, I think it's, by the way, use workflow is a very interesting and very well executed idea experiment. Okay, I don't know if it's going to if it's going to stick, but it's really interesting. Okay, let's talk a little. Let's unpack it what it is. Okay, at the source, at the high level, top level. Okay, it provides a durable workflow engine similar to Temporal. Okay, at the very high level. Okay, it's you write JavaScript code, you write TypeScript code, you write TypeScript code. Okay, you have your TypeScript code that you write. You write the workflow in TypeScript, you write the steps in TypeScript, those things are durable, okay? So essentially the process can crash, restart, and the steps will continue executing. Okay, that is what it is, and at the very high level. So you can see, it quacks the same thing, but with a very nicer developer experience. But
hold on, sorry, Theo, just for me to understand, I have use workflow, right?
Yes.
As a
yes. So a directive. So what it does, okay? So you write the workflow file. Let's put it here. You have to write the workflow files and the steps, okay? In Temporal, you have the workflows and the steps, okay? Conceptually, it's in that size, it's similar.
Yeah.
With in Temporal, the client, the way you need to write those two things, okay? Yeah. It's very explicit, okay? You need to use the SDK, okay? You use their SDK to do those things, okay?
Yeah, I was actually reading to have some code in front of me, okay?
Yes, okay. So you write the SDKs, okay? You use the SDKs. With use workflow, okay, instead of using the SDKs, you put this magic directive and it all magically happen at compile time. So the code that you write is very different from the code that is going to be executed. There is a massive delta between the two things.
But sorry, Theo, just a question. How does he kind of like capture, like it's because, sorry, just like for dummies. I do use workflow, and then I have all my code with async, await kind of like model, right? And at compile times, it basically takes every async await declaration.
It converts, no, not exactly. It converts the use step, okay? Instead of returning just the function, it converts it into some sort of durable objects, okay? That stores the input and output, the input and the result of that execution, okay, in the database.
But I could build the same, having a function called useStep.
Okay, sorry, but it's the developer experience. Okay, the key focus on use workflow of the workflow dev kit is developer experience.
Yeah, but at the price of basically being handcuffed with the whole Vercel ecosystem, right?
Let's go into let's dig a little bit into that for a second, okay? Because it's very important. It's a very different the model, okay?
And it's compile time, you said, right?
This is compile time, okay? All of this is compile time. Then you need to store those things somewhere.
But
Okay.
sorry, Theo, why didn't they make it runtime if they have a use step?
Yes, but you sorry, I have not finished. Okay,
Uh-huh.
this compile time create this step and workflow abstraction to execute your workflows. Okay,
Uh-huh.
then you have the concept of word.
Okay, the one where
Okay.
we live, basically.
Yeah, that's the thing that actually does everything. That's the runtime. Okay,
Okay.
the word. Okay, it's you can have in memory word, which of course if the process cache is gone, you can have a Postgres word, you can have a Vercel word, you can have now people have created a AWS word. Okay. Basically, in this nice globe, that is the word. Okay, what the responsibility of that, okay, is to store. It's actually providing the durable execution
Yeah.
for your workflows.
So it's an adapter pattern.
It's exactly an
Okay.
adapter pattern.
But it's cooler to call it
Word.
world.
Yes.
Yeah. Okay.
Yes, it's cooler to call. It's cool. It's an interesting idea. Okay, I'm just mentioning it's an interesting idea. Now, in
Sorry, I'm reading the code because it's kind of like.
I want to stress the difference between something like this and something like temporal. Okay, because I think there is a. So the complexity of those systems, okay, and it's in providing the durability and reliability. So, in essence, the complexity of those systems are in the runtime. Okay.
What do you mean? Sorry.
So it's how do you handle versioning of your workflows? Okay. How do you upgrade your workflows? How do you make your workflows observable? How do you I don't know, do all those things that are absolutely that are very important for the life cycle of the workflow itself. Okay, and in fact, temporal is a server plus some SDKs. Okay, use workflow. Okay, does not have that. Does not follow that pattern. Okay, use workflow is an SDK essentially, and then where you inject the word. The word provides the runtime, which provides all the nice enterprise level features.
I don't know. I think it's just a bunch of not invented here syndrome with the nice UI, like sorry, experience.
Yes, is it DX developer experience?
Yeah, but sorry, just not to make it too. You don't really need the compile time to do that because you could do inversion of control at runtime, right? I mean, in Java theory, did the same. Come on, it's like
in theory, yes. In practice, it will be way more clunky. Okay, in way more clunky in JavaScript to do that.
But why? Because I think, I mean, I understand the whole thing, right? But I'm thinking in .NET or in Java, I would probably write my step function and put a nice attribute and say, so decorate it as a step, right? And then you take advantage of the compile time there, right? It's a little bit more thing.
Well, it's not the compile time though. Those are can be interpreted at runtime.
Correct. True reflection. But the thing is, I don't really understand, and maybe it's me. I don't really see the compelling advantage of using this.
Okay, so there are two bits. So if you, for me, the way I see it, the compelling advantage is Vercel needed durable execution durable workflow execution pattern for their cloud, and they developed it. And for that, it's essentially the SDK.
Yeah, but because behind the scene, what they do, they will discriminate by
it's the Vercel
probably,
word, right? There is
yeah,
the Vercel
from
word.
some AI or some machine learning that will basically recommend you which machine to use, and so they go into the
Yes.
promise of optimizing cost.
Exactly,
and so on.
exactly.
Okay, but okay, but I can build my own world, right? So I can basically write my own world that runs on
Exactly.
Kubernetes.
But then the question at that point is, will it be as reliable as Temporal?
No, on that one I don't have doubts, to be honest. I'm not doubtful on the skills that Vercel's team put into building that. It's not.
Yeah, no, but sorry, I'm.
My
You
thing
said
is,
you can write your own. You said you can write your own. Did you write your own? Like this is what I mean. You write your own, okay? So
in what
far,
sense? Like of your own word or your own
your own
workflow
word,
engine?
your own word.
Yeah, but I'm just kind of like thinking maybe it's me, right? But
Like so far, there are two built-in word, which is the embedded file system based, which is useless, okay, for production, and there is the Vercel word. There is a community provided built on top of Postgres.
so it means that in the World SDK, they have all the different steps for saying save step,
It's just
hydrate
an adaptive
step.
pattern, so you just load an npm library that does this implement the word.
Yeah, and you need to write your own kind of like logic and so on.
Yes.
My only concern. I mean, I like the developer. I like the idea of the developer experience. Right? I think it's pretty compelling, like you were saying.
Yes.
But at the same time, my kind of like problem there is, do we really need to define it as a step? Like my ideal world is where developers don't have to think about the concept of workflow. It's inferred it's inferred by the runtime, right?
But that's exactly the premise of the workflow dev kit.
But you need to use a step.
Yes. Well.
So I need to declare. But why not actually having something that can? I mean, if you're already at compile time, why not actually have a normally async await mechanism and let the user kind of like take every single function and throw it into a durable execution?
You can't really, because there are serialization boundaries between it, and you cannot. You could doing with I don't know, some JIT, doing some JIT magic, okay,
But
doing some language level, runtime level type of, oh, I am serializing a closure. How do I serialize a closure and save in a database and then deserialize that in the future? Okay, do I even want that to do that? Okay,
but
because I don't, by the way, this is a bad idea. And the reason it's a bad idea is because I want to be able to change the implementation of that function over time. Okay, so that, if there is a bug, I can fix the bug. Oh, there is an input that I didn't know how to handle. Oh, I'm fixing the bug. Okay.
But that's, I mean, to me, I mean, I'm just thinking, it doesn't take much to basically, even if do something ugly, eval of the text.
Yeah.
And every time that you reprocess in a deployment the code, you traverse all the code tree and apply new deltas to all the functions. So you build a graph on the function dependency.
Yeah.
And then you call eval. I know that is bad. I'm not saying that is good, but absurdly, I think it would be probably easier to build a sandbox function execution Right. I think because they don't do memory. They do mem copy or other stuff? Do they do any magic?
They serialize all those systems, even temporal, serialize the input and outputs of the workflow, the individual step execution.
Okay, but that's easy, right? Because we know
it's just JSON. You just store it somewhere. Yeah.
No, but even if I do mem binary, it's fine because I know
fine.
the size off, right?
Yeah.
I don't know. It's
look, I'm like I'm thrilled by the developer experience. I am skeptical on any execution that's not Vercel based. Essentially, they're great engineers, so I presume that their execution on their platform will work very well. But it's
but think about step functions. Think about simple workflow engines. The Java one that everyone uses, I don't remember the name. It is a commercial product. There are plenty, and
now I just wanted to throw a last something that we didn't plan to talk about. Okay, that was just published. Today. Okay, it's I'm pasting here, Luca, in the chat. Okay, let me see if I can paste in the chat. Okay, I'm pasting this in the chat. Where is it? Okay, in the chat. Okay, here we go. I'm pasting it in the chat. No, I can't. Where is it? Sorry, Luca. I'm passing it in the chat. It's a post from Armin Ronacher. I don't know if you know Armin is he worked at Sentry, created a lot of open source, and he is probably one of the greatest engineers of our time. Okay. He created Flask, I think, or worked a lot in Flask in Python. He's very big in the Python ecosystem. Okay.
Yeah, and I saw actually the same.
You saw the article, right? So basically, he created a similar implementation for a similar implementation of that system just by using TypeScript and Postgres. Okay. And it's called it's very interesting. It's a very interesting implementation. Okay, so and that system does not require a compile step, and to be honest, the code looks pretty good.
Yeah, what I really like is, I mean, you and I have been talking about an idea that I think we're gonna just like hack together because it's too interesting not to do it. But I don't think we should. Well, I'm surprised that in 2025 we are still on the quest of defining even an execution primitive, which is kind of like absurd to me. Like I was expecting that those things was like an out of the box kind of like functionality, right, of distributed runtime. So maybe what we should do, after you and I design it and we're ready to release it, we should kind of like, I don't want to say stage it, but almost, not to kind of like, but we should have like a banter where we go through a live design that clearly we will already have done of the system and try to basically for our launch.
Let's see if we end up building the thing, okay? And if we do, let's see how it goes.
Yeah, that would be interesting. Well, we chatted for our usual more than 3/4 of an hour. It was extremely interesting.
Amazing.
If we had no time limit, I think we would talk about it for like 6 hours. A little bit like Lex Friedman's podcast when he interviews Elon Musk and other people, that it takes hours and hours. So yeah, till then, let's chat next week.
Bye. Bye.